So in this video, we're going to solve a consecutive integers problem. But before we jump into solving a problem, let's talk about a consecutive integers problem or a consecutive numbers problem. So three consecutive integers. So consecutive just means one right after another. So for example, the numbers 2, 3, and 4 are three consecutive integers. And the issue is typically that we don't know what the integers are to begin with, so we need to represent them with variables. So for example, I could represent three consecutive integers by saying, hey, I'm the first integer, n sub 2, I'm the second integer, that's a horrible n sub 2, number 2, the second integer, and n sub 3 could be the third integer. And the key is that we want to recognize that if we have three consecutive integers, that if we know what the smallest one is, the next one in line we just get by adding 1 to the smallest of the three consecutive integers. And when we get to the third one in line, we would get that by taking the first integer and adding 2 to it. So there's a sense then in which we could represent 2, 3, 4 as 2, 2 plus 1, 2 plus 2. But in the case where we don't know what the integers are, we still know that they're going to be separated by 1. This one here is going to be n sub 2 plus 1. And there's going to be a difference of 2 between the first and the third. 3 minus 1 is 2. So I can represent three consecutive integers using just the smallest integer by taking the smallest integer, then taking the smallest integer and adding 1, then taking the smallest integer n sub 1 and adding 2 to it. So I can represent it as n sub 1 plus 1, n sub 1 plus 2. The smallest plus 1, the smallest plus 2. If we had three consecutive even integers, and we were representing them with variable names, n sub 1, n sub 2, n sub 3. The key is when we're trying to solve a consecutive integer problem, we need to represent all three using just one of the three. So again, we can think about it by looking at a concrete example. We can say, hey, let's suppose I have three consecutive even numbers. Right there they are, 2, 4, 6. Well, if I take the smallest, I can get the next one by adding 2 to the smallest, because there's a difference of 2 between any two consecutive even integers. 6 minus 4 is 2, 4 minus 2 is 2. So if I have 2, I can get the 4 by taking 2 and adding it to the 2 that I started with, and I can get the 6 by taking the 2 that I started with and adding 4 to it. So 2, 4, and 6 can be represented as 2, 2 plus 2, 2 plus 4. So in the abstract case where I don't have concrete integers, I can still do this. I can say, hey, take the smallest even integer. To get the next even integer, add 2 to the smallest one. To get the third even integer, take the first one and add 4 units to it. And now I have three consecutive even integers, all expressed in terms of just a single integer. And just to look at one more example, if I have three consecutive multiples of 3, so 3 in a row, I could still represent them n1, n2, n3. Here's three consecutive multiples of 3. But if I look at multiples of 3, let's say let's start with 6. 6 is a multiple of 3 because it's equal to 3 times 2. So the next multiple of 3 up would be 9. And the next multiple of 3 up would be a 12. There will be a difference of 3 between any two consecutive multiples of 3. 2 times 3, 3 times 3, 4 times 3. So I could represent the 9 and the 12 using the 6. I could say, hey, I have the number 6, 6 plus 3, and I have the number 6 plus 6. So in the generic case, I would say, hey, I have the first multiple of 3. To get the next multiple of 3 in line, I'm just going to add 3 to the previous one. And to get the third multiple of 3, that's consecutive relative to the first, I just add 6 to the smallest multiple of 3. So we can use that principle to solve a consecutive integers problem. So this says solve the consecutive integers problem by modeling it with a single variable linear equation. And so we'll read through this. We'll say when the smaller of two consecutive, so 2 in a row, of two consecutive integers is added to 3 times the larger, the result is 51. Find the smaller integer. So now I'm going to sweep back through this, and I'm going to give things a little bit of labeling. So when the smaller of two consecutive integers is added, so we're going to take the small integer. Let's represent the small integer with n sub 1. When the smaller of two consecutive integers is added to 3 times the larger, let's make n sub 2 represent the larger. So n plus 1 plus 3 times n sub 2. The smaller is added to 3 times. The smaller is added to 3 times the larger. The result is 51. And so the issue here is I have an equation, but the equation has 2 variables in it, and I'm asked to solve it by using a single variable linear equation. So what I need to do is to find a way to express these in terms of each other. So the first consecutive integer is n sub 1, but what we know is that the next consecutive integer is just going to be 1 bigger. So we get n sub 1 plus 1. So in other words, so if we had 3 and 4, then we could represent the 4 with a 3 plus 1. We could just add 1 to the smaller. So what this means, as my thing pops up, what this means is that n sub 2 is just equal to n sub 1, the smaller integer, plus 1. So in the equation, I can take n sub 2, so there's n sub 1 plus 3 times n sub 2, and I can replace n sub 2 with n sub 1. Add 1 to the smaller, and that's the same as the next consecutive integer. Add 1 to the smaller guy, and you get the next integer in line. And then once I do this, I have a linear equation in a single variable, and I can just solve it. I have 51 here. I have n sub 1 plus, distribute the 3 into the parentheses using the distributive property, so 3 times n sub 1 plus 3 times 1 is 3. I have like terms. I have 1 n sub 1 here plus 3 n sub 1s here, so that's going to give me 4 n sub 1s plus 3 equals 51. I need to get the n sub 1 by itself. I would like to know what this first integer is. So I'm going to take and subtract 3 from both sides. So 3 minus 3 is 0. 4 n sub 1 plus 0 is just 4 n sub 1, and 51 minus 3 is 48. And then to get n sub 1 by itself, I'll divide both sides by a 4. So 4 divided by 4 is 1 n sub 1. So there's 1 n sub 1 right there. And 48 divided by 4 is 12. So this is the smaller of the two integers. This is n sub 1, and n sub 1 represents the smaller. If it asked me to find the consecutive integers, then I recognize that if n sub 1 is 12, then n sub 2 is just going to equal the n sub 1 plus 1 more. It's going to equal the n sub 1 plus 1 more. So it's going to be the 12 plus 1 is 13.